Hello guys and welcome back. So now we're going to start looking at the statue rise scene that I showed in the beginning, and I have a few things to start with. First is a very simple environment. So these are some rocks that I copied over to build this simple surrounding for the statue, and then the statue also has a base to it, and it's going to move and rotate at the same time. And this motion is created in Houdini. This is a scan that I downloaded. I'll share the link for it, and I'll share the geometry as well. So let's dive inside and take a look. So this is the first ground plane, ground geometry. This is the second surrounding for that piece, and this is the statue. Delete this. And I think the statue, I think this is the original mesh. I just did a clip at the base here to trim out some extra geometry that I didn't like to, and to have a flat plane, so it can merge it nicely with the rest. And then I scaled them up and positioned them in this way. Cleaned up all the attributes. I don't need this guy. Deleted all the attributes just to make sure that everything is clean. And then I created this animation in Houdini with a simple transform node and a rotation and a Y change, so it moves along the Y axis. Okay, cool. And then for the environment, it's very simple. Just everything is one piece of geometry, and it's very low res. I have a high res version of this that I use for rendering, and I will share that next week when we start doing rendering. But for the simulation purpose, this is going to be enough. Now, the sim prep, let's see, yeah, I'll talk about this in a second. So the main issue here that we need to solve is we need to fill in an interesting area with flip fluids, with particles basically, and that area is going to be everything inside this. We cannot have particles inside this geometry. For example, we cannot use a box and just fill it and have it intersect with everything. We need to carefully place in the points where we need them to be. And if we don't do it this way, then we have to create a ground collision for this and then start pouring in flip fluids to fill in correctly the entire space, and that's going to take a huge amount of time, and we may not get to the same result that we want. So the best approach is to do it procedurally and find a way to place the particles correctly inside this area here, and then we're going to have the statue come up and intersect with everything else. So for now, I'm going to hide this. We don't have to worry about it, and we need to focus on creating the particles. What I've done is I created a tube geometry, and if we look at the top here, you can see this is the geo. I then transformed that point a bit, and I extruded it up this much. And I'm gonna show where I use this, but for now I'm interested in this part. So what I've done is I extruded it all the way up, okay, and I'm gonna use this fake volume to group the particles that are inside this area and delete them, okay. And we're also going to use this geometry and delete any particles that intersect with this volume. So let's create a geonode. Call this flip init, and let's grab a copy of this and create a null. Call this outinv. Okay, and That's my environment. I'm also going to need this guy, not this guy, sorry, the bound geo. I'll share the shortcut. I have a shortcut that creates an input, an object merge from any node. So I'll share that. So I have these two guys, and I'm going to create a particle fluid tank. And let me check the size. Okay, so I'm gonna set it to 20, 7, 20. The center is going to be 2.5. Cool. And let's see. That's it. It's our base geometry. I think I'm gonna, I'm gonna increase the scatter density to 2. And let me check one more attribute. I'm gonna increase the water level to 1, so we have a thicker volume. And let's lower this to 0.1 to have more points. Okay, so the next thing is we want to group the points that are intersecting with the geometry. So group node, and this guy has a where is it? Group by region, and in here we can use a group volume. And I'm gonna connect this guy, and I use the volume because this is a more accurate method to use. I'm gonna convert this into a volume, so I'm gonna use a VDB from Polygon, and that's our VDB volume from this geometry. And we need to change it to a fog volume and make sure it's set to points. And let's turn off this. Yeah, so it needs to be an SDF, sorry. So those are the points inside inside the geometry. I'm gonna remove them. Actually, I think we can just do a delete. No, sorry. Yeah, it does not. So I'm gonna use a delete node, delete points, and then I'm gonna do the same thing for this guy. And this is just, it's gonna grab everything else outside. Okay, and we still have a few more points, and we can see they should be I think the water line is a bit high, so I'm going to lower this to 0.5. And there we go. I have something there we can fix by hand if we wanted to, but basically this is the main important part for the scene. Now the cool thing about this is because it's procedural, we can change the density of the points, and that will still propagate, and everything should work just fine. Cool, so let's call this out flip, or yeah, out flip source. I'm going to do, I want to grab this, so I'm going to do a VDB reshape. and this we can expand, we can erode or dilate a map, an SDF. So this is the original. This is after we offsetted it by 1 voxel. I'm gonna change it to 2, and that should make it, it will grab those points. Cool. Okay. Flip. Let's create a dot network. Sim flip. And let's copy this. Sorry, make a floating tab so I can use these values in the flip sim. And let's create a flip solver. Let's create a flip object. And the same thing here. I'm gonna initialize it with that, with the flip that we created. I'm gonna copy this, paste relative reference here. Let's connect this guy. And then for the display, change it to particles, and under the volume motion, I'm going to copy this, paste relative reference, copy this, paste relative reference. Okay, and I'm going to tick on the collision. We can also change. Yeah, we'll keep the boundaries closed for all of them. I know it's not gonna go up, and I want to reduce this a bit because I know the particles are not going to be moving up a lot. So maybe something like this. And the more precise the domain is, the faster the sim is going to be. Okay, let's see how much points we have. Cool. And now, before we proceed, if we hit play now, actually let's put down the gravity and hit play. See, the particles are just going to slide and start moving. There's nothing holding them up to stay in place. And that's very, very normal. Okay, so we need to import the geometry and use it as collision geo. So first of all, we need the environment, and I'm going to convert this into a VDB from Polygon, and we're going to use our own VDB for the collision, and that looks okay. Yep. Let's call this out inv VDB. Let's copy this path. Dive inside. I'm going to create a static geo, and this is actually a static geo, so there's nothing fancy here. I'm going to merge this, and we're going to specify the VDB volume like we did. This is the most efficient way. So volume sample, and we're going to specify the VDB volume. If we take a look at collision geo, cool. So that's our geometry with the collision geometry being previewed. So this should help. So let's hit play. And as you can see, because the points are, we know that there is no points inside any of this geometry, and we've used that to delete the extra points. We know that all this is going to get some kind of collision surrounding it. This guy is, our selection didn't do a great job, and unfortunately we have to create an extra geometry surrounding this to overcome that, or we have to modify the geometry a bit. And this is part of working with Flip. There is nothing automated to fix all these kinds of problems. We have custom geometry, which is very complex, to be honest. Here, I mean, it may look simple, but there's a lot of cavities, there's a lot of intersection, and we have to work with that. So the extra geometry is actually very, very simple that I'm going to introduce, which is this guy here, the tube that I made. And it just extruded it a bit. And I'm going to use it to enforce the boundaries. So I converted it into a VDB. Sorry, it looks like, yeah, I have a newer version. Looks like the edit I have here is not the same, but we'll use the saved one. I think I know why this may be happening. But basically this is the geometry that I like to use, and this is the same one as well. So it's not this. The edit had some issues, and it didn't keep the selection that I wanted. But this is the silhouette that I used. Okay, let's import this now. So object merge this. Back into dops, static geo again, and let's merge these two guys. And it's always a good idea to enforce or set this section, enforce it to make sure that it's run as a static geometry by using a static solver. And this static solver, this is always a good practice to have this node after all your collision geometry, whether it's deforming or not. Okay, so this is boundaries, and this is going to be called VDB. Let's hide this. Cool, so that's gonna enforce this area where there was leaking. And let's make sure that the collision geometry is working. Now see, I forgot, I always check this to make sure that everything is set up correctly. We need to change this to volume sample. And now it looks better. And I'm going to, because I don't have a copy of this, what I'm going to do is I'm going to use a VDB convert and convert this, the VDB that I have saved to disk, which has proper silhouette. I'm going to convert it back into a mesh, and I'm going to increase the adaptivity. Yeah, something like that. And use this as a geo instead. Okay. Cool. So now we have both of them. I'm going to hide this extra bound. I don't want it to be displayed. Just the static environment. And I'm going to change the display to pixels. And all I want is basically for this to stay in place. We're going to see a little bit of movement. There's nothing wrong with that. We have to do some pre-roll for everything to settle in, and then we can start introducing our forces. And I think we have everything in place now. Let me check the length. Okay, so we're going to do one last thing here. See that there is that small ripple, which is fine. So I'll have to do some pre-roll, and then start introducing our sim. But for the sake of speed, I'm not going to do any pre-roll. I'm going to have everything starts at frame 1. Hopefully everything will look good. Now what I want to do next is I want to introduce the statue as a collision geometry. And what I've done is let me copy this. So I have this sim prep node, and I have the statue section. As you can see, this part here is quite high res, and it has open. It's open from the bottom. I didn't like that, and we have to fix that if we wanted to do a proper collision. So I simply replaced that part with a closed tube. Instead of having, I didn't use this. Sorry. Yeah, I didn't use this part, and instead I used a tube, and this way I can have a better geometry to collide with. And this is something that we always have to work on. There's a lot of preparation with the geometry that you will receive to create something that is airtight and efficient to work with Flip. Most of the issues that you see when Flip explodes and things like that is because the geometry, Flip is not liking the geometry. Okay, so let's go back to SimPrep. And this is the simplified version with the same ground. Sorry, see the points are always in the viewport. That's the OpenGL not refreshing. Yeah, so now it's working. So I'm going to keep the ground, I'm going to keep the statue, and I'm going to use this new tube geometry. Okay, then I apply the animation, same animation, and we have our geometry. But I also want to do a VDB from this, and we can do a VDB from polygon from these guys, but this will mean that we have to regenerate the VDB every frame, and this is going to be really slow if we wanted to go high res. So instead I'm going to generate the VDB once when they're at static position, something like that, and then I'm going to copy the animation, and this way I don't have to cook the VDB every frame, just one time. Let's see how much resolution. We can go to 0.3, and let's do a trail node after this. Make sure we have our velocity vector. Okay, and let's create a null. Out statue geo, and let's copy this. Out statue VDB. Let's go to the flip, and again create a static object. Paste the path here, and we need to use deforming geometry and reevaluate SOP to make sure that all the points and attributes are properly interpolated. I'm going to change this to volume sample, and this is going to be VDB. And now we have our geometry there. Let's show collision. Cool. Okay, let's see how much points we have now. 400. I'm going to increase this to, let's see how much. Yeah, this is cool. I'm going to turn on caching. I want to cache this in the scene. Let's change this to 30. And I'm going to hit play. And I'll pause the video and we'll continue in the next one. Thank you guys for watching, and see you in a bit.